Emostel.
Hello, you're welcome to this video. This is Emmanuel Kadri of Emostel Academy. In this video, we are going to be discussing natural logarithm, which is the fourth part or the fourth video in the series on logarithms. All right, so what makes it natural? Why do we call it so? What is so special about it? Join me as we take that ride. Okay, now we call it natural logarithms because it deals with these constants, which we can call the natural number. Okay, that number is called the Euler's number, which has the value of 2.718. It is just like this pi, this normal pi, 22 over 7 approximately, or 3.141, blah, 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 and all this, which we approximate to 3.142. So it's just that same thing. Okay, it's a constant number just like the pi. All right, so in advanced level mathematics, you will know Mr. Euler, how the Euler number came to be and everything, but it's not just the scope of this class for now. Okay, so, but we call it natural logarithm. It is a special kind of logarithm in which the base is the Euler's number. A special kind of logarithm that, unlike we having base 10, base 2, base 5, base whatever, like all of these other ones that we've been dealing with, in this case, we are dealing with the base E, where E is the Euler's number. The logarithm that has to do with base E has a special notation called ln. We call it ln. N standing for natural, while L is logarithm. This is small letter L. It is not IN, it is actually ln, where this L is logarithm and this N is natural. So the combination Ln stands for natural logarithm. Okay, so this ln is still just like the short form. Ln x is a short form of log x to base E. Ln x is a short form of log x to base E. Okay, so this is just, and every rule that applies to regular logarithm also applies to the natural logarithm. Okay, as you can see here, ln xy is ln x plus ln y, just like log xy is log x plus log y. The same thing happens here too. The quotient rule applies the same way. Sorry, this plus is minus. It's writing error. Okay, so ln x over y is ln x minus ln y. Okay, please. And then the power rule, x raised to power r. Okay, ln x raised to power r is r ln x. And then ln 1 is equal to 0. All right, and then ln, like I told you earlier, the logarithm of 1 is always equal to 0 regardless of the base. The logarithm of 1 is always equal to 0 regardless of the base. And then here we have it, ln e is equal to 1. How do we come about this? If we say ln e equal to 1, remember that ln x is equal to log x to base E, right? And so when we say ln e will now mean log, instead of x, we now have e to base E. All right, and we know that logarithm of any number to the same base that is the same as this base is always equal to 1. And so that's the reason why we have ln e being equal to 1, just as we have it here. So it's quite simple. So just have it at the back of your mind that ln e is equal to 1. Okay, good. So having said all of this and recited all of those rules, let us quickly solve all of these questions and then we call it a wrap afterwards. Okay, question number 1. Simplify or expand. So let's do 1a, which is ln e raised to power 5. ln e raised to the power 5. How do we solve that kind of question? So remember that all the rules of logarithm, the rules that apply to normal logarithm also applies to this. So ln e raised to the power 5 is just going to be simplified as 5 ln e. Okay? 5 ln e, and there's nothing special about it, right? So, but remember, the question says ln e is equal to 1. So instead of writing 5 ln e and leaving it that way, we just say 5 multiplied by 1, and the answer is 5. It's that simple. Now, let's quickly check out for the B. B says ln 4x raised to the power 3. Altogether, ln 4x raised to the power 3. Okay? So we apply the product rule. The product rule will be like ln 4, okay, plus, because they are multiplying, so you share the ln across 4 and x raised to the power 3, but it is going to be separated with plus according to the law. Then we have ln x raised to power 3. Good. So we have ln 4 plus ln x raised to power 3 according to this law, which says ln xy is equal to ln x plus ln y. So you split the two of them, okay, and share the ln across, separating them with a plus. All right, so we understand that ln 4 is like ln 2 raised to power 2, then plus ln x cubed, okay? So this 2 goes here. We have it as 2 ln 2 plus 3 ln x. 2 ln 2 plus 3 ln x, okay? Right, and then there is actually nothing we can do more at this level, because we cannot find the value of ln x if we are not given what ln x is, okay? But if you still want to, convert it to normal logarithm or something like that, you may now say, okay, ln x, according to here, ln x is log x to the base e, but you don't really need all of that. Okay, instead of you doing all of that, it will still lead to nowhere. At the end of the day, you will still have the logarithm present in the answer. So to cut the long story short, you stop here because the question asks you to simplify it or expand it, so which you have done, and you stop exactly there. There is nothing more you can do. Okay, so now the next question, the C part. The C part says 3 ln A plus half ln B minus ln C. Simplify. No problem. Okay, just take this one as ln A raised to the power 3 by reversing this, and then plus ln B raised to the power half by taking this here, minus ln C. So if you have it that way, since these two are adding, you can have everything to a common logarithm to all of them, and then the addition changes to multiplication by us saying a raised to the power 3 multiplied by b raised to the power half. Okay, subtraction changes to division, and then we have C. Okay, all right, so you can decide to stop here, or you write it as ln A cubed root B divided by C. Ln A raised to the power 3 root B divided by C. This also goes because b raised to the power half is the same thing as square root of b according to the law of indices, okay, which we have treated before. Okay, law of indices that says a raised to the power x over y is equal to y root a raised to the power x. So, which means this is 1 over 2, right? The 2 goes to form a root, which is square root. And when it is a square root, you don't need to put the 2 there. And then b raised to the power 1, okay? Since 1 is the numerator, it carries the power, but we don't write 1, 2, because it's invisible. All right, so you can decide to leave your answer this way or you leave your answer this way. You are good to go. So we are done with the whole of question 1. Now let's quickly move to question 2. All right. You can just pause the video and take a record of everything. Okay, so we don't need these notes anymore. So we can still tick it off. All right, let's solve the second one. To solve for x in each case, we have ln x is equal to 3. If ln x is equal to 3 and you need to find the value of x, well, the simple thing you can do here is to find a way to make the both side to have ln. You get that? Okay. Otherwise, since you know that ln x is log e, but you don't even need that. So ln x is equal to 3. Find the value of x. So the best thing to do here is to make it like ln x is equal to 3. Since you understand this rule that says that ln e is equal to 1. So instead of writing, if you want to introduce ln, you can just put on the other side. Or you can just say ln e. Since ln e is equal to 1, just say ln e. Okay? And then in this case, you have ln x is equal to ln e raised to power 3. Ln e raised to power 3. Okay? At the end of the day, you can break it out in both sides, and then you have x is equal to e raised to power 3. And that's all. And you know the value of e is given as 2.718. So you can just put it there, 2.718 raised to power 3, to find the actual value of x, and you are good to go. All right? So if you care to do it that way, still fine. If you care to leave it this way, it's still cool. But the value of x, as far as this question is concerned, is e raised to power 3. Okay? Okay, so the next one is ln 2x is equal to 4. Good. So to solve this question, we may just want to put the ln on both sides by introducing, and then you remember the law that says ln e is equal to 1. So you can just try to put it on the other side by saying ln 2x is equal to 4 ln e. Since ln e is equal to 1. So the idea is just to make ln to be on both sides so we can be able to cancel it out. And then we have ln 2x is equal to ln e raised to power 4. All right, this 4 goes as according to the power rule. So now we have ln on both sides, so they can just cancel out. And then cancelling out, this gives us 2x is equal to e raised to power 4. Right? Then since we are solving for x will be e raised to power 4 divided by 2. And that is the final answer. Except if it is needed for you to insert the value of e and find the final result from there. But if that is not needed, that is just the answer and you are good to go. Okay? All right. So we move to the third one. The third one says ln x squared plus 1 equals 0. If ln x squared plus 1 is equal to 0, this is even quite easier because we understand that ln 1 is e0. So knowing that ln 1 is 0, so you put it there that ln x squared plus 1 is equal to ln 1. Is equal to ln 1. All right? So it's ln 1. Now, we have ln on both sides, so they can cancel out. And then you have x squared plus 1 equals 1. And then, instead of us to take it to quadratic equation and all of that, whenever we are dealing with logarithm, we usually aim for the positive answers. So since it is the positive answer is our answer of interest, so let's just move on by saying x squared is equal to this 1, all right? There was a 1 here, then plus 1 goes to the other side as minus 1. X squared equals 0, then x equals 0. All right, but if you want to take it down, if you want to take it quadratically, you will say x squared plus 1. You bring this 1 here, but even though you intend to do it quadratically, you will still end up getting 0, because when you bring this 1 here to the other side, you have x squared plus 1 minus 1 equals 0. Then you have x squared, plus 1 minus 1 is 0, then x squared is equal to 0, so x is still equal to 0 either ways. All right, so the square root of 0 is still 0. Okay, so let's move to the next one. The deal says 2 ln x is equal to ln 9. 2 ln x equals ln 9. If 2 ln x is equal to ln 9, we have it that ln x is equal ln x raised to power 2 equals ln 9. If ln x raised to power 2 is ln 9, then we have ln x raised to power 2 equals, ln can cancel out ln, so you have x squared is equal to 9. And then x is the square root of 9. We are interested in just the positive answer, so we don't need to say plus or minus the square root of 9. Just say the square root of 9, then x is equal to 3. Okay? And if you don't want to take it this way, you can still say x squared is equal to 3 raised to power 2, which is 9. And so, since we have equal power, then we have equal base, according to law of indices. So we said x is equal to 3. So that also works. Either way you want to do it, you are good. And so I think we've really done a lot so far. All right, so this is where we call it a wrap on the topic on natural logarithms and how you can just solve them in questions. Okay, so now that you have the basic idea, you can apply the idea to solve as many questions as you want. So many questions, just go out there, get questions to practice with. If you find any question difficult to solve, you could just send it across for us to just expatiate on it and explain it to you. All right, but for you to be able to do that, you need to join us. All right, so just join Emostel Academy by going to emostelacademy.org and click on join now, and then select your category to see you on the other side. Take care of yourself, and please solve a lot of questions. Remember the Emostel rule. Number 1 is for you to learn. Number 2 is for you to understand. Number 3 is for you to practice what you already understood. And then number 4 is to excel. Bye for now.